right, so when we spent these last couple days doing that discovery lab where we were working with the tiles and you were arranging the different expressions into rectangular shapes, what we were doing there was introducing this concept of factoring expressions. And you guys took to it very well. I was noticing the work you submitted the other day. You guys were able to identify what it takes to be factored and what it looks like when it's not factored. That was great. So a couple vocab terms here. The first one is factor, and this is, I had to clarify, this is the verb version of it. When we factor an expression, we write the number as a product of its factors. And the GCF, which we talked about the other day when we had our bell ringer, it's just the largest factor that a group of numbers will share. And you were certainly aware of that prior to the other day. So let's just get into a couple of examples here. Like one was like the bell ringer. Okay? And it wants us to find the greatest common factor for two terms, 25x and 15xy. And we're going to take our time with this one just to develop it a little bit more. But I think eventually you're going to settle into a strategy that's going to work best for you. So 25x. I think the way that most of us prefer when we talk about factors is just to do a list of all of the possible factors. All right, so can somebody give me, why don't we just call them out? Give me some factors of 25. You can just say them and I'll write them. 1, I heard. 5. Is that it? 25. Okay. Did we get all the numerical factors? And then we have the variable factor of x. Very good. Okay. But numerically, yeah, it's 1 times 25 or 5 times 5. Those are the factors that we're talking about there. And then obviously we have that x, so that's considered a factor of this term. Likewise, we're going to go 15xy. All right, call them out. What do you got? 1. X and y. We'll list them as two separates. Good. So now that we've listed all of the possible factors, our goal here is to find the greatest common factor. So numerically speaking, what is our greatest common factor between these two terms? Okay? 5. Okay? That's the largest number that appears in both of these lists. But do they share any other factors? Emily? An x, exactly. There's also an x in both lists. So we would say that our GCF for these two terms is 5x. We factored those two terms. Now the other way, like I had said when we did the warm-up question, was to use the prime factorization way. Now I'm going to make a prediction. You guys aren't going to like this way as well. Maybe I'll be wrong. I don't know. But 25x, we're going to list all of the prime numbers that factor out of this, okay? Which means, well, 1 is always one of the factors. But in this case, it's 5 times 5. 5 is a prime number. 5 times 5 gives you 25 times that x. Now 15xy would be 3 times 5 times x times y. 3, 5, both prime numbers. You have your x and your y. And you're going to go through and find any common factors. Well, in this case, it's 5 and it's x, just solidifying the point, like we said earlier, that it's 5x. I don't care which way you do it. In fact, we're developed enough that I don't even need you to make a list unless you feel like you need it. So I'm not going to require, oh, where's your list of all of the factors? I don't need to see it. If it helps you and you feel more comfortable with it, absolutely do it, but not required. Okay? So let's take a look at another set here. 48x, 28x. Let's just do this one, and then we'll have you do the next two on your own. So I'm going to go the thorough route here. I'm going to list them out. But if you want to try at your seat, if you want to try to do it without listing them, that's an option as well. I'm going to list all of the factors here. So I'm thinking 48. I go 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. A lot of terms, a lot of factors there. And the x. I didn't do the prime factorization. I just listed all the factors. 1 times 48, 2 times 24, etc. 28. 1, 2, 4, 7, 14, 28, and x. All of the numbers that divide evenly into 28x. So scan those two lists. Tell me what you see as the greatest common factor between both. Nadia? Just 4. All those factors, 4 was the largest number that they shared. Okay? So our GCF on the line would be 4? 4x, right? They also share the x. So GCF, 4x. There you go. All right. Why don't you give these next two a shot on your own? Just work them out. Write your number or factor on the line there. I'll come around and take a look at it. Looking at our work out there, most of us are choosing to create a list of the factors, which is great. That works. That helps us to not miss any when the time comes. Would somebody do me a favor that created this list and tell us what you listed out for 16S? All of the factors. Go ahead, Max. Looks good. 40 has more factors. Thank you. Good. So what is the Greatest common factor then? Ava? 8s, right. 8 is the largest number, s is the only variable, so our GCF here is 8s. Okay? 42mn and 18mn. I noticed when I walked around, many of you right away had written mn down. That's good. Yeah, you see that those are factors. That's fine. And then you can all you really need to do is focus in on the coefficients here, 42 and 18. What did you determine the greatest common factor was between those two numbers, 42 and 18? What did you get? Jack? Yeah, 6 was your GCF, so it's 6mn would be both terms. Cool. Yeah. Yeah, like I agree with that. Yeah, if you determine that, you know, like I said, I don't even need you to make a list. So if you see that when you're making your list, absolutely go with it. All right, good. Now let's take a look at how we factor these expressions. And this is going to be more familiar to you, I guess you could say, because this is what we were doing the other day. We want to factor this expression 12x plus 48. Now, the other day, remember I gave you those tiles, and you had algebra tiles. So you would have 12 of the green algebra tiles and 48 of the blue cubes, which I didn't do that many. But the job for you would be to arrange them into a rectangle. And once you've arranged them into a rectangle, then you've essentially factored this expression. Well, when you arrange them into a rectangle, what you're going to notice is that the number of rows, and I'm just making this example up, this isn't necessarily for this one, the number of rows that you have would represent one of the factors. I'll show you what we mean by that here in a minute. So look at 12x and 48. Step 1 says let's find the greatest common factor for those two terms. Any ideas? Kate? It's 12. Very good. Yep. GCF is 12. Awesome. Okay? Now what that means is that I could take those tiles and I could arrange them into 12 identical rows. If I arrange those into 12 identical rows, what would be in each row? Like what tiles would be in each? It says here, use the distributive property, which means we're essentially working in reverse of the distributive property. Instead of multiplying through, we're taking out the term that goes outside the parentheses. Nadi, what do you think? Each row is going to have 1x plus 4. Now, how did you get it so quickly, Nadia? You said you divided 48 and 12 by 12, by the GCF. Exactly, right. So you're taking this 12x plus 48, and you're dividing each of these terms by the GCF. You're thinking, like, how many, like, what is going to be in each row if I broke this up into 12 identical rows? Well, 12 divided by 12 is 1, so it's 1x. 48 divided by 12 is 4. You're going to have 1x plus 4. Now, here's the thing. Since we factored out the 12, we're going to write it in this form right here. It says, use the distributive property to write this expression. Well, we're going to write it just like that. How do I know if I'm right? Or how do I know if there's ways to factor. How do I know that I've created a proper factored expression? Jack? Yeah? Yeah, you just distribute right back through. 12 times x is 12x, 12 times 4 is 48, and it works out to be the same. Okay? There are other ways to factor this. Can you think of a different common factor, not the greatest common factor, but a different common factor between 12x and 48? Cameron? 2. So what if I did this? 2 groups. What would be in each group? Like if I only had 2 rows of these tiles. Use the way that Nadia described right here. What's going to be in each? Go ahead, Cameron. 6x plus 24. Now, if we go back to what Jack had just told us, if we checked it, 2 times 6, 2 times 24, you're going to get the same expression. All right? Let's look at a different one. What's another common factor? We've got 12, we've got 2. Frankie? We've got 6. So if I factor out a 6, what would be 6 groups of what? What do I need to put in here so that when I distribute it back, it gives me the 12x plus 48 expression? Jack? 2x, because 6 times 2x is 12x. 6 times 8 is 48. You seeing how we're getting these? We'll do one more, because we didn't do 4. 4 groups. A lot of factors shared here. So 4 groups. What would be in each group? Aiden, what do you think? 3x plus 12. 4 times 3, 4 times 12. Okay, so let's just recap. We determine a factor, a common factor. What are you doing with this factor to get the expression inside the parentheses? Like what do we do with the 6 to get 2x plus 8? What do we do with the 4 to get 3x plus 12, etc.? Go ahead, Jen. Or in this case, just any common factor, the way we're doing it. Yeah. Multiply through. Very good. So you're dividing each of the terms in the expression by that common factor. The answer, though, that I wanted, when I ask you to factor the expression, I always want you to try to factor it with the greatest common factor. Okay? Because here's the thing. This 2 times this quantity, 6x plus 24, it's still not fully factored. Because 6x and 24 share a common factor. Up here, 2x and 8 share a common factor. 3x and 12 share a common factor. So you're always going to be, unless you get the GCF, you're always going to have more factoring to do. That's why I want you to go there with it. All right, let's try to get this next one. 6n minus 24. What's your GCF? Between 6n and 24. Brooke? 6. So we're looking for 6 groups of what? What would be in each group? Max? Well, 6 groups of what? Like, yeah, imagine the rectangle. I have 6 rows. Ava? 1. Yeah, 1n minus 4 or plus a negative 4. Either way. Good. Down here. I'm going to actually, let's work backwards on this. Look at letter C. Just for time, I want to make sure we get this. Look at letter C. The goal is to try to find the greatest common factor. See any problems here with C? See any problems with C? C. That was yes in Spanish. C. Mara, what do you see? The only greatest common factor, the only common factor here is 1. So here's the, in a case like this, if I gave you 4x plus 35 tiles and said arrange into a rectangle, what's that arrangement going to look like? Do you remember? What's it going to look like, Kate? Yeah, just the row, right? Just a long row. That is the only way we can factor this. But we wouldn't say, oh, you would just do like one group of 4x plus 35. We would say on this one, cannot be factored. Or C, B, F. Cannot be factored. No, I'm not making it up. That actually is an acceptable usage of that. Yeah. But yeah, if you only find one as the common factor, then we would say that it cannot be factored. These other two could be factored. They share a common factor here of 4. So it would be 4 groups of what? 4 groups of what? Go ahead, Emily. 1x plus 7. Good. I always get B. People are like, oh, that cannot be factored. Yes, it can. What's the GCF? Jack. 3. And what do I have inside, Jack? Good. 1 plus 11x. Okay? So that's what you're going to be working on tonight. The problems out of the book look similar to this. You may encounter a couple that you're going to have that cannot be factored. But don't forget about the con stuff, too. Please put your iPads back. I thought we were going to get time to go. Just drop them off back there, please.